Ever wondered if we could break the cosmic speed limit set by light itself? Just imagine if we could traverse galaxies in the blink of an eye, reach out to distant civilizations, or even travel through time. It's a tantalizing thought, isn't it? But alas, our current understanding of physics puts a speed limit on the universe. Nothing can move faster than light, or so we've always been told. Yet the human spirit thrives on pushing boundaries, doesn't it? On asking, what if? And so we find ourselves drawn to the tantalizing possibility of faster-than-light travel, a concept that's as intriguing as it is controversial. We're talking about wormholes and warp drives, theoretical constructs that might just hold the key to cosmic speedsters. They're not your everyday concepts, but they might just be our ticket to the stars. So let's dive into these fascinating theories and see how they could potentially make the impossible possible. What if we could take a shortcut through the fabric of space-time itself? Imagine you're in a vast, sprawling forest, and you need to get from one end to the other. You could follow the winding paths, but that would take time. But what if there was a tunnel that cut straight through, allowing you to bypass the long and winding route? That's essentially what a wormhole is. A shortcut through the fabric of space-time, a tunnel that connects 2 points in space, potentially light years apart. Now, these aren't ordinary tunnels. These are theoretical tunnels predicted by general relativity, the same theory that gave us black holes. In essence, a wormhole is a solution to the equations of general relativity that describes a tunnel-like connection between two different regions of space-time. This means that if you were to enter a wormhole, you could emerge somewhere completely different, potentially even in a different time. But before you start packing your bags for a trip through a wormhole, there are a few challenges to consider. First, there's the question of stability. Theoretical physics predicts that wormholes, if they exist, could be highly unstable, collapsing the moment anything tries to pass through. To keep a wormhole open, we'd need something called exotic matter, a type of matter that has negative energy density. But here's the catch. We're not even sure if exotic matter exists. Then there's the problem of creation. Even if we could find or create exotic matter, we still don't know how to create a wormhole. The theoretical mechanisms that could create wormholes involve conditions and energies far beyond what we can currently achieve. So, while the idea of wormholes is fascinating, it remains firmly in the realm of theory for now. We don't have any evidence that wormholes exist, and we're a long way off from being able to create or use them. But don't be disheartened. Intriguing as they are, wormholes remain purely theoretical for now. But there's another concept that might offer us a way to travel faster than light. Imagine if instead of moving through space, we could make space itself move. Now there's a thought. This is the principle at the heart of the Alcubierre warp drive theory, named after Mexican physicist Miguel Alcubierre. Picture this. You're a surfer. The ocean is space-time, the surfboard is your spaceship. And the wave? The wave is the warping of space-time itself. In this scenario, you're not actually moving through the water. Instead, you're riding the wave, letting it carry you forward. This is the essence of the Alcubierre warp drive theory. Instead of propelling a ship through space, the theory suggests that we could warp or stretch the fabric of space-time itself. So, how does this work? Imagine a piece of fabric stretched out. Now place an object on one end and another on the opposite end. Instead of moving the objects towards each other, what if we could stretch the fabric from behind one object and compress it from the front of the other? The objects themselves haven't moved, but they are now closer to each other. This is the concept behind the Alcubierre warp drive. Of course, this idea isn't without its challenges. For one, it requires something called exotic matter with negative energy density, which is still purely theoretical. Additionally, the energy requirements for such a drive are astronomically high, potentially more than the energy available in the entire universe. Nevertheless, the exploration of these theories is ongoing. Researchers around the globe are studying the Alcubierre warp drive theory, probing its implications and attempting to overcome its challenges. The potential implications of this theory are mind-boggling. If possible, it could revolutionize our understanding of space travel, potentially allowing us to traverse vast cosmic distances in a blink of an eye. While the reality of faster-than-light travel remains uncertain, the exploration of these theories certainly propels our understanding of the universe forward.